The solar system is a vast collection of planets, moons, asteroids, comets, and other celestial objects bound to the Sun by gravity. It extends far beyond the 8 major planets, encompassing countless smaller bodies and a multitude of intriguing phenomena. Understanding the solar system not only helps us comprehend our own place in the cosmos, but it also provides clues about how other star systems and planetary systems might function. Formation of the solar system. Approximately 4.6 billion years ago, the solar system began forming from a giant molecular cloud, a dense, cold region of space filled with gas and dust. A shock wave from a nearby supernova likely triggered the gravitational collapse of part of this cloud, leading to the formation of a spinning disk known as the solar nebula. Over time, matter within the nebula clumped together through a process known as accretion, gradually forming the Sun at the center and the planets around it. The Sun, the solar system's star. The Sun, a G-type main sequence star, is the central body of our solar system. It holds 99.8% of the solar system's total mass, exerting the gravitational force needed to keep all the planets and other objects in orbit. The Sun generates energy through nuclear fusion in its core, where hydrogen atoms are combined into helium, releasing tremendous amounts of energy as light and heat. This energy supports life on Earth, influences weather patterns, and drives climate systems. The Sun has several key layers. The core is the energy-generating center where nuclear fusion occurs. The radiative zone, where energy moves outward by radiation. The convective zone, where energy transfer occurs through convection. The photosphere is the visible surface of the Sun. The chromosphere and corona are the outer layers visible during solar eclipses. Solar phenomena such as sunspots, solar flares, and coronal mass ejections can affect Earth by causing geomagnetic storms and auroras. Planets of the solar system. The solar system contains 8 major planets, categorized into 2 main groups: terrestrial planets and gas giants. These planets differ in composition, size, and position relative to the Sun. Terrestrial planets. The terrestrial planets, Mercury, Venus, Earth, and Mars, are rocky and dense. They have solid surfaces with varying landscapes, such as mountains, valleys, and craters. Mercury, closest to the Sun, has a thin atmosphere and extreme temperature fluctuations. It has a heavily cratered surface, similar to Earth's moon. Venus, known as Earth's sister planet due to its similar size and composition, has a thick, toxic atmosphere composed mainly of carbon dioxide. Its surface temperature is the hottest in the solar system due to a runaway greenhouse effect. Earth, the only known planet with liquid water on its surface. And life has a stable climate and a rich atmosphere with a balanced blend of oxygen and nitrogen. Earth's magnetic field and atmosphere protect it from harmful solar radiation. Mars, known as the red planet due to iron oxide on its surface, has seasons, polar ice caps, and signs of ancient river valleys, suggesting it may have had liquid water in the past. Gas giants and ice giants. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are massive planets with thick atmospheres primarily composed of hydrogen and helium. Jupiter, the largest planet in the solar system, is known for its Great Red Spot, a massive storm. Its strong magnetic field and extensive system of moons make it a mini solar system of its own. Saturn, recognizable by its intricate ring system, is also a gas giant with numerous moons, including Titan, the second largest moon in the solar system. Uranus, an ice giant with a unique tilt, rotates on its side, giving it extreme seasonal variations. Its atmosphere contains water, ammonia, and methane, giving it a blue-green color. Neptune, another ice giant, has dynamic weather with the fastest winds in the solar system. Its atmosphere is rich in methane, which contributes to its deep blue color. Dwarf planets. Beyond the 8 major planets, the solar system also contains dwarf planets, smaller celestial bodies that orbit the Sun but have not cleared their orbits of other debris. The 5 recognized dwarf planets are Pluto, Eris, Haumea, Makemake, and Ceres. Pluto, once classified as the 9th planet, was reclassified as a dwarf planet in 2006. It has a thin atmosphere that freezes when it moves farther from the Sun, and its largest moon, Charon, is nearly half its size. Ceres, located in the asteroid belt, is the largest object in that region and the only dwarf planet located in the inner solar system. Eris, Haumea, and Makemake. These dwarf planets reside in the Kuiper belt, a region beyond Neptune filled with icy objects. Moons of the solar system. Moons, or natural satellites, orbit many planets in the solar system. Some moons are geologically active with volcanoes or geysers, while others are ancient and cratered. Earth's moon. Earth's only natural satellite affects tides and has a synchronous rotation, meaning it always shows the same face to Earth. Jupiter's moons. Jupiter has 4 large Galilean moons, Io, Europa, Ganymede, and Callisto, each with unique features. Europa, for example, may harbor an ocean beneath its icy crust. Saturn's moons. Saturn's largest moon, Titan, has a thick atmosphere and lakes of liquid methane and ethane. Enceladus, another moon, has geysers that spew water into space, suggesting a subsurface ocean. Neptune's moon Triton is unique because it orbits Neptune in the opposite direction of the planet's rotation. It is believed to have been a Kuiper belt object captured by Neptune's gravity. Asteroids, comets, and meteoroids. The solar system contains numerous small bodies that provide insight into its early history. Asteroids are rocky bodies mainly found in the asteroid belt between Mars and Jupiter. These objects range in size from small rocks to dwarf planets like Ceres. Comets. Composed of ice, dust, and rock, comets originate in the outer regions of the solar system. As they approach the Sun, they develop tails of gas and dust. Comets are thought to come from the Kuiper belt and the distant Oort cloud. Meteoroids are small fragments of asteroids or comets. When they enter Earth's atmosphere and burn up, they create a streak of light known as a meteor. If they reach the Earth's surface, they are called meteorites. The Kuiper belt and the Oort cloud. The Kuiper belt. Extending beyond Neptune, the Kuiper belt is a disk-like region containing icy bodies, dwarf planets, and comets. Pluto, Eris, Haumea, and Makemake are some of the larger Kuiper belt objects. The Oort cloud. This is a theoretical, spherical shell of icy objects that surrounds the solar system and marks its boundary. Thought to be the source of long-period comets, the Oort cloud is far from the Sun and remains largely unobserved. The solar system's future. The Sun, currently in the middle of its life cycle, will continue to shine for another 5 billion years before exhausting its hydrogen fuel. As it ages, it will expand into a red giant, likely engulfing Mercury and Venus, and possibly Earth. After shedding its outer layers, it will leave behind a white dwarf, a small, dense remnant. The planets and other objects will gradually drift farther apart as the Sun loses mass and gravitational influence. The eventual fate of the solar system, like all star systems, involves a gradual disintegration of orbits or collision of planetary bodies over astronomical timescales. The solar system, our home in the vast cosmos, is a dynamic, interconnected system filled with wonders that reveal the complexity of the universe. From the Sun's life-giving energy to the farthest reaches of the Oort cloud, each component provides insight into the origins and evolution of planetary systems. Understanding our solar system helps us better appreciate our own existence and gives us the tools to explore beyond.